This past weekend, my primary focus has been on developing the U-axis, bringing it to life by designing it, printing the plastic pieces, and assembling it. In this video, you will see how I handle things. I deal with problems, keep them from getting out of hand, and sometimes I even put them on hold. I know that ignoring some problems sounds a bit strange, but my priority is to make a functional MVP, and I don't want to waste time and effort spiraling down into details right now. I plan to break down the project into three main aspects: hardware, firmware, and software, and I will be analyzing the problems and concerns I have as they present themselves. Just heads up, I am not a professional in electronics or industrial design. However, I do have a background in software engineering. But for the purpose of this project, I am essentially a hobbyist. Therefore, success isn't guaranteed. My primary objective is to explore this concept and see where it leads me. If all goes well, we will have a fully functional system from hardware to software, but that is a significant amount of work. However, I hope that at the very least, my efforts here will add value to the open source community from which I use a lot of code in daily basis. So I will be releasing this 5-axis frame as an open source project for others to build. I want to clarify though that I will share it only when I believe it's a decent design, somehow usable in his version 1 with some reasonable effort. Not perfect, but good enough to be picked up and developed further without the need for a complete overhaul. I am eager to hear what the 3D printing community thinks, and that is why I am sharing this project from such an early stage on YouTube. I welcome any constructive criticism in the comment section. In fact, I am hoping for participation, as I don't presume that all my ideas will be the best ones. Many brains are better than just one. In terms of those videos, they are not meant to be entertainment, but that doesn't mean that they have to be plainly boring. I will present the situations with a good degree of detail in a way that if you are an enthusiast of any kind, you should be able to grasp the challenges I am facing, why they exist, and how I am planning to tackle them. I also want to do this for others to save time and effort in the future, and for me too, since I have a painfully short memory. As the different parts of the project reach completion, I will most likely create tutorial-style videos for anyone interested in building something based on the thing I want to achieve here. Now, regarding the slicing, I think that's one of the most uncertain parts of this project. A quick research shows people slicing in SolidWorks using quite a complex process. I am also considering trying to adapt the 5-axis manufacturing features in Fusion 360 somehow. Maybe a post-processing script to convert the CNC movements into 3D printing commands. An alternative is creating a custom script in a familiar programming language to produce some sample G-code and demonstrate the concept without the fully fledged slicer. I can imagine a future where slicers can be as complex as CNC software that allow the user to choose among a lot of strategies to slice a model. I anticipate that this will be my main side project of 2023, and I am sure I will get to a point where this is useful somehow for some other people as well. It could take me a while to get there anyways, so stick around by subscribing if you are interested. With that said, let's dive into this week's progress. About the architecture of this printer. You may be wondering why I choose to maneuver the printing surface rather than the print head. It boils down to two main reasons. First, I want to take advantage of gravity. If I just move the print head around, I could as well print on the sides of the part, but I would still be restricted by gravity, continually pulling down, requiring support for my print and forcing us to rely on support material. If we're talking about 5-axis printing, it seems logical to expect less reliance on support material. Another problem, if I want to make the head move in X and Y while also rotating in U and V, is that such assembly will be heavy and complex to design, and I prefer to split the problematic bits into two physical assemblies. But, like all decisions, there is a cost to it. There is a risk of the print falling off the bed if it's shaken too aggressively. Also, there is a need to fine-tune the print surface to be in line with the print head. We will discuss this later. About the process, I started designing a mockup with the actual printer measurements and created animations to visualize how this would work. I have picked up some skills in Fusion 360 over the years, though I haven't used it consistently. My approach may not always be the quickest or the best, but it works for me. This time in Fusion 360, I didn't do anything that magic. I just used traditional techniques that can be found in any other tutorial on the web. That is why I will probably not focus on Fusion right now, but in the future if you see me doing something and you think you have a better way, please let me know by commenting below. After finishing that quick mockup and looking it around for a bit, I decided it was not that bad. Then I continued by hiding the dummy parts and designing the real thing. Probably a better way to approach this would be to model the whole 3D printer before beginning any part print. But this approach seemed a bit dull to me, and that doesn't play well with my strategy of starting with the unknowns and then moving to the known parts of the project. If I was to play the screencast of the design in real time, you will notice that I haven't modeled every tiny screw or nut, because it turned out to be a bit tedious in other occasions when I did. I am just showing it speeded up because it's hours long and I don't want to convert this in a Fusion 360 tutorial. I am cutting some corners here by designing the plastic parts, then printing and testing them. If I mess up, which by the way I did a lot, it's quicker to fix it in the software and then print again. I am fully aware of how wasteful this approach is, but I am going to recycle these old prints one day. Once I was happy with the Z and U and I had left the space for the V axis, the printing began, and I soon had plastic parts all over the place. I had planned to reuse the assembled frame, but a quick inspection showed room for improvement. I'm not a fan of using these angles to join the profiles. In the past I drilled and tapped the holes for stronger structures, but that is a tedious process, and also I haven't settled on the dimensions of the printer yet. Let's save the final decision for later, so I am not forced to do the drilling just yet. Expectedly, I needed to reprint nearly every single part at least once. There were changes in tolerances, screw sizes, or simply because the part I envisioned in my design would not work well in the real world. I originally intended to use just one linear bearing per rail, but play was an issue, as we can see here. 2 bearings were necessary to partially get rid of it. In the future, I will be reworking the Z axis. I think I can get away with attaching U and V assemblies to Z by a single point with just one single linear rail. The most painful part was to cut the profiles to the right size. I have this CNC machine I made by using a project that can be found on the web called IndieMill. I left the link in the description, but all the electronics and motors are a bit bigger. I also used Linux CNC in there. The machine is a pain to use because I live in an apartment and it's incredibly noisy and dirty, plus it doesn't have a surface and lives on the floor of my home office. But it is quite powerful and precise, and I want as much precision as I can get for the reasons I will share later on this video. The second most painful part was tapping the holes. There I discovered that I designed for M5 screws and I should have used M6. Aside from having to fix, reprint and retry some parts, the build was pretty smooth. Some of the pulleys I had are not well suited for this project and I had to work around it. I will do it for now, but I have already ordered the parts I need to replace those workarounds. Now I want to explain some of my current concerns about this project, but be aware that we won't reach a conclusion about them just yet. I think I need more data to fully understand what we are dealing with. To explain this better, I prepared this animation in Fusion 360. Picture a shape we want to print, like a square pipe with an unconventional hook on the side. Printing the base is straightforward, raising the Z and then lowering it while X and Y paint with plastic. Here each axis operates independently. However, if we want to create that particular hook, we can call on our new axis. So we drop Z, give U a 90-degree spin, raise Z again, and get X and Y lined up. I have chose this particular shape because it demonstrates an intriguing effect. When we adjust U, both Y and Z start to shift as well. Even more intriguing, the rate of change depends on U's position. Another point to note is the layering when we use rotational movement. It's subtle here, but we will use less plastic in some places and more in others. This means adjusting the flow to cater for the compression of layers closer to the center of rotation. Otherwise, we run the risk of over-extrusion. The same principle applies to the V axis. Let's think about the situation where I can infinitely rotate V and want to create some shape similar like a vase. Just as the thought exercise, let's say I don't have the constraint of the cables pulling. We would need more flow the farther we are from the rotation center. Alternatively, we could keep a steady flow and just change the speed at which V rotates. At this stage, those scenarios seem to pose an issue for the slicing software, not for the firmware. From what I understand, the printer controller is just following the G-code instructions and managing the motors. It doesn't really analyze whether those movements make sense or not. It's probably too early to be talking about these problems, but it's something I want to keep on the back of my mind. I feel this is just another thing that can be baked into the slicer code. How difficult that will be is the real question here. Next on my list is to talk about precision. Well, consider the U-axis for example. If it's not perfectly perpendicular to Y and parallel to X, we will need to adjust for that. It could also be non-concentric, causing an offset of a few millimeters, and we could also face similar issues in the V-axis. In the past, we had a similar problem with the heat bed. Prints would fail because the nozzle was either too close or too far from the print bed, since there was no way of sensing and compensating for imperfections. So we had to manually calibrate it, and that was a really frustrating process and almost never worked well. Now imagine how much harder this problem gets when dealing with tolerances of printed plastic, aluminum pieces cut at home, and parts ordered online with less than ideal precision, all while considering 2 more axes. I suspect that the last points I mentioned are more of a firmware concern. The printer controller should have the logic to feel the printing surface and calibrate it using clear maths, like we now do to calibrate for print bed imperfections. Without that, successful printing will most likely be a game of luck. There are a lot of unknowns and concerns, but I am confident that there are solutions to all of them. I am eager to learn and share those learnings with all of you as I make progress. So here is where we are right now. Next time I will show you the work I've been doing on the X and Y gantry. My plan for the weekend is to assemble it. After that I will dive into the controlling electronics. Even before finalizing the printing head, the printed surface, and even before I completely figure out the V-axis. Why? Because I'm keen to explore the firmware and see what's there and what needs to be developed. There actually is some open source stuff online that I can use, and I want to see how much of it I can take for this project. Best case scenario, there is firmware out there that already supports 5-axis, and I will just need to configure it. Worst case scenario, there is nothing reusable, and that means I will have to code a lot. Either way, it's gonna be an interesting challenge. Thanks for watching and see you next time.